Two of the most common types of programming are procedural programming and object-oriented programming. Procedural programming is the simplest form, where the program is divided into procedures or functions that are executed sequentially one by one. Languages like C use procedural programming.
What about the other one?
Object-oriented programming revolves around the concept of objects and classes. Languages like Java, C++, and Python support OOPs. Let's look at 10 basic concepts of object-oriented programming that every programmer should know, starting with class. Think of a class as a blueprint for an object. It contains various attributes and methods. Attributes are the properties of the object, while methods can be considered as behaviors or the functions of the objects. Think of it like this. This is the Samsung S24 Ultra, and there are thousands of S24 Ultras out there. So, these are objects. But Samsung makes this phone using a blueprint, which contains details about the specifications of the phone. So that blueprint can be considered as a class, and using class, we can create so many objects. Let's create a phone class. First, we will define its attributes like brand, model, RAM, etc. Attributes are simply variables in the class. Then, a class can also have some methods. Methods and functions are the same. When we define functions in the class, we call them methods. Here, think of it like the functions of our phone, such as making a call or displaying phone information, the actions that the phone performs. We have defined attributes and methods, but still this class is incomplete. How are we going to set the values of these variables? We can use constructors. When creating a phone, a blueprint is designed by designers and the parts are made or assembled at the factory according to the requirements. Then a phone is created. Think of a constructor as a factory that creates the object. It is a simple function, or we can say method since it is inside the class and has the same name as the class. When we create an object, the constructor is called automatically. So we can pass the details like RAM and all that to our class using this constructor. The constructor will then assign those values to the attributes of the object that will be created. Our blueprint is ready. Let's create an object. An object is simply an instance of a class. In simple words, anything we create using a class is an object. Similarly, like two different S24 Ultras have their own RAM, memory and features, every object has its own attributes and methods. Since I am using Java, this is the syntax to create an object. We need to pass all the details that our constructor needs in this parenthesis, like model, RAM and storage. Now we can access the methods and attributes of our object, like let's see the phone information. In the same way, we can create another object using the phone class and access its attributes and methods. Now, let's make a call with both of them. After this, we have inheritance. It is a concept that allows a class to inherit attributes and behaviors from another class. For example, S24 has base model and the Ultra model. These two phones are almost same with some upgrades in Ultra model. So while making, they may take the base model parts and only change the required components. So we can say Ultra model inherited properties of base model. This is our phone class. Let's say we want to create an Ultra phone class, which will have all this stuff, RAM, storage and all that, and also all these methods. But it will also have new property, color, and a new behavior that displays color. The bad way is to simply copy paste all this code in the new class and then add our extra attributes and methods. This is the bad approach because we write the same code again. The right way is to simply inherit these properties. In Java, we write our new class name, then the extends keyword, and then the name of the class whose properties we will be inheriting. As I told you earlier, our Ultra phone will have a color attribute and a method that displays the color. Everything will stay the same. Here, phone class is the parent class and our Ultra phone is the child class. Parent class is also called as superclass and child class as subclass. Now, while creating the constructor of our Ultra phone, we need to pass the value to the constructor of our phone class. We can access the constructor of our superclass using the super keyword and in parentheses the value for the constructor. Then let's assign the given color to our color variable. Now, when I create an object of the Ultra phone class, I can access the methods and attributes of our Ultra phone class as well as of our phone class. Next is encapsulation, which includes bundling data, that is attributes, and methods into a single unit and controlling access to them. In a phone, different components are bundled together. Similarly, in a class, different attributes and methods are bundled together. This is the first part of encapsulation, bundling. Next is controlling access to the data items. In our normal phone, when we try to access something like the RAM, it's not simple. The RAM component is protected. We need to follow step-by-step instructions to remove it, or we risk damaging our phone. Similarly, if we change our RAM, there are limitations. We can't just insert 1 GB of RAM into our phone. Right now, if I want to access the RAM of my phone, I can directly do it via myphone.ram. And I can also change the value without any checks, like this, myphone.ram equals 1. Now the value is 1. To control the access of our RAM, we can make it private. In this way, if we try to directly access or change the variable, we will get an error. So in this way, we have restricted the direct access to our variable. But how do we access it? We can do that using a method. To access the value, we can create a method that returns the value of our RAM. This method is also known as getter method because it allows us to get the value of our variable. Now simply call the method to get the value. But how do we change the value of our RAM? For that, we can define another method that will change the value of our RAM. This method is also known as setter method because it sets a new value to our attribute. We can simply call the method to change the value of our RAM variable and we see the updated value. But why is this important?
Why go to all this trouble?
Well, in this way, we can control access to our attributes. For example, in our setRAM method, we can check if the new RAM value is less than 8. If it is, we will print an appropriate message because we don't want our RAM to go below 8. Otherwise, we will update the value of our RAM. Now, if I try to set the RAM to 1, we will see a too low message and our RAM remains unchanged. So this is one benefit of encapsulation. Next, let's move on to abstraction. Abstraction refers to the concept of hiding complex details and only exposing necessary details. Consider a phone. Every phone has basic features like calling and displaying phone information, but we don't know the details of how these features are implemented. So our phone also uses abstraction to hide the complex details. Have a look at this code. We've got the phone class with a variable brand and two methods, make call and phone info. But they are only declared. There is no body for these methods. These types of methods are known as abstract methods, and we declare abstract class using the abstract keyword in Java, which contains these abstract methods. Here, we are hiding the implementation details of these methods. But where are we going to write the body of these methods? In the subclass of the phone. Because we cannot create an object of the abstract class directly, we first need to extend it to another class and define the method bodies of the abstract methods in that class. Then we can create the object and access everything normally. Abstraction has another advantage. We can have different versions of our methods in different classes. For example, in this Galaxy Note 20 class, our method also prints stylus information, which is different from the Galaxy S21 method. Both will work fine and we won't have any issues. By the way, an abstract class can also contain non-abstract methods, which makes it more powerful. However, while abstract classes are powerful, they have limitations. For example, a class can only extend one abstract class. But what if we want to implement behavior from multiple classes? For that, we can use interfaces. Interfaces provide a way to achieve multiple inheritance in Java. An interface contains only abstract methods, which means non-abstract methods are not allowed. To declare an interface, we use the interface keyword followed by the interface name, then the abstract methods. If we want to implement this interface in our class, we need to use the implements keyword followed by the name of the interfaces to implement. Yes, we can implement multiple interfaces at once separated by commas. Then in your class, declare the body of the abstract methods. We can easily call those methods without any issues. So we can say these abstract classes and interfaces are also like contracts, requiring the implementation of these methods. If we don't implement them, there will be errors and we don't want that. Now on to method overriding and method overloading. Method overriding means declaring the same method with the same parameters again in the subclass but with a different method body. For example, in our phone class, we have the makeCall method. If I create an object of our subclass and call the makeCall method, the makeCall method from our superclass is executed. However, if I declare the same method again in my subclass with different logic, then when calling the method, the code from the subclass is executed. In this way, if needed, we can change the logic of the methods for our subclasses through the concept of method overriding. Now on to method overloading. It means having multiple methods with the same name but different parameters. For For example, here we have the makeCall method which takes a number as a parameter. If I declare this method again without any parameters and make it print no number given instead of calling, then we have overloaded the method. Let's declare one more makeCall method that takes both a number and a sim number as parameters and prints calling number with sim number. Now, if I call the method with just a number, the method with the number parameter is executed. If there is no number, then the method with no parameters is executed. If there are two parameters, number and sim number, then the respective method is executed. All of this can be achieved through the concept of method overloading. Next, we have static members. These variables and methods that we declare in our class do not belong to class itself. When we create an object of the class, memory is allocated for that object, and in that memory a separate copy of these variables and methods is stored for each object. That is why these variables and methods are also called as instance variables and methods. So if we create two objects, two separate copies of all instance variables and methods are created for each respective object. This is why we write the object name and then access those instance variables and methods from that object. For example, if we try to access the storage attribute directly from the phone class without an object, we will get an error because it does not belong to the class but to the instance of the class. But what if we want an attribute or method to belong to the class instead of the instance? We can make that attribute or method static using the static keyword. For example, let's make the storage attribute static, give it a default value and remove it from the constructor. Now, when I create objects of the phone class, the storage is same for all objects, which is 128. This makes sense because we set the default value to 128. But if I change the value of the storage using phone1, the storage value of phone2 is also changed. I can also access the value of the storage variable directly from the class. This is because since we made the storage attribute static, it belongs to the class only and its value is shared among all objects. There is just one copy that belongs to the class and the same copy is used by the objects too. Now same goes for methods. If I make the method static, I can directly access it without creating the object.